Okay, this is a video for the section 1.1 review of graphs examples that I would like you to go over in your class notes. So in this section, notice that the learning objectives are plotting points in the rectangular coordinate system, graphing equations in the rectangular coordinate system, using a graph to determine intercepts, and interpreting information given by graphs. So I have 4 examples here that I'd like to go over with you to help you understand and do well in the homework. The first one is to graph y equals x cubed minus 2 by letting x equal these 7 different points, minus 3, minus 2, minus 1, 0, 1, 2, and 3. So I have this on the next page for you to fill in. But what we're doing in that is this is simply plotting by plotting some points. So here's the equation, y equals x cubed minus 2. And then if I have a little table here for x and y, to construct points on which we're going to plot. I'm going to let x equal minus 3, minus 2, minus 1, 0, 1, 2, and 3. So all you have to do is plug those values of x in for x into our function. Do some simple arithmetic and you get the values of y. So the first point you'll plot is the point minus 3, minus 29. And here is that point, minus 3 on the x-axis, minus 29 on the y-axis, etc., etc. And when you fill that in, connect the dots with a smooth curve, and that is simply the graph of y equals x cubed. Looks very, that's a common graph I'd like you to recognize. And the minus 2 means that it shifted 2 units down on the y-axis, and we'll be talking much more about shifting of functions later. Okay? So going back, the second example is to determine the x and y intercepts of the graph below, just by looking at a graph. So in other words, the x-intercepts are where the graph crosses the x-axis, where the y value is 0. So the x-intercepts, this is the x-axis. So the x-intercepts, this first guy right here is at x equals minus 2. The origin is right here, so this is x equals 0, and this is x equals 2. The y-intercepts are where x is equal to 0. Okay, so if x is equal to 0, the y-intercept is just this guy, with the one value that crosses the y-axis actually ends up being at y equals 0 also. The third example here is to write the English sentence below as an equation in 2 variables. The y value is the difference between 6 and 3 times the x value. So the word is represents an equal sign. The y value equals, so y equals. The difference means we're subtracting something. So we're going to subtract the difference. We're going to subtract 6 and 3 times. So 6 minus 3 times x. 6 minus 3x. Okay. And then the fourth example is to graph these simple equations. Again, we can let x be those 7 different values. So if we go to the last page of section 1.1 notes, these are actually simple to graph. They're constants. Y equals minus 3 is just a graph of y equals minus 3. No matter what x value I stick in, there is no x value to stick in. So y is simply minus 3, which is that straight line across at y equals minus 3. Similarly, in this one, graph x can only be 2. So for all of these other values of x, y is not there. There is no y for any of these other values of x except that x equals 2. So when x is equal to 2, y can be anything, so it's just a vertical line. So we have a horizontal line of y equals minus 3 and a vertical line of x equals 2.